Hi Year 9, this is our third lesson for the topic of trigonometry. In this lesson we're going to learn how to find an unknown angle. So far we've learnt about labelling the sides of a right-angled triangle, the trig ratios, sine, cosine and tangent, how to use the calculator, about degrees and minutes, and the last lesson we learnt how to find an unknown side. Now recall that if we want to find an angle we have to solve this trig equation here. With any equation, we want to get the pronumeral by itself. So we want theta is equal to something. So I've got to move this sine. Now the opposite operation of sine is inverse sine. And so what we do is we take it over the other side and it becomes sine to the power of -1. Or we could write it like this. And then we just put that into the calculator. Now there's the full readout. That's in degrees. We could be asked to do it to 1 decimal place, or we could be asked to do it to the nearest degree. Also in the first video, we learned how to use the calculator and the degrees, minutes, seconds button to change this readout into degrees, minutes, and seconds. And from there, we can write this angle to the nearest minute. Okay, let's have a look at an example. So find the value of theta to the nearest degree. So just like before, we're going to label the sides. We're always going to start with the hypotenuse, which is opposite the right angle. So here's our hypotenuse here. Locate the angle. This time it's going to be a pronumeral. Opposite the angle is the opposite side, and next to the angle is the adjacent side. So we have got opposite and adjacent, which is SOHCAHTOA, it's tan. All right, again, use this as a formula. So we've got tan of the angle, so tan theta is equal to opposite, which is 4, over adjacent, which is 10. Now we need to move the tan over the other side. So remember, it's going to come over as inverse tan. So we rewrite it. Theta is equal to inverse tan of 4/10. We just put that into the calculator, and we want it to the nearest degree. So it's 22 degrees. Let's try another one. Find the value of x to 1 decimal place. So again, we are going to label the sides. We'll start with the hypotenuse, which is opposite the right angle. There it is. Locate the angle. Opposite the angle is the opposite side. Next to the angle is the adjacent side. So this time we have got hypotenuse and adjacent. Now, that's not ringing a bell for me because I've written it the wrong way around, but that's all right. SOHCAHTOA. Let's have a look. We've got hypotenuse and adjacent. There it is. So it's cos. Cos of the angle, so cos x, is equal to adjacent, which is 7 over 17. Take our cos over the other side. Cross him out, goes over as its opposite operation. So x is equal to inverse cos of 7 over 17. Into the calculator, we want it to 1 decimal place, so it's 65.7 degrees. Okay, let's try 1 to the nearest minute. Same method. So start by locating the hypotenuse. It's opposite the right angle. Then locate the angle. Opposite the angle is the opposite side. Next to the angle is the adjacent side. Okay, so we've got O and H, SOHCAHTOA, so it's sine, and sine x is going to be equal to 14.6 over 18.9. Then we're going to take the sine over to the other side. So cross him out, comes over as inverse sine. So x is equal to inverse sine of 14.6 divided by 18.9, and we put it into the calculator. Now this time we're going to press the degrees, minutes, seconds button. So it's going to give us 50 degrees, 34 minutes, 39.82 seconds. And we want it to the nearest minute, so we want to chop it here. Look at the next one. 39 is greater than 30, so we're going to round up. So our answer is approximately 50 degrees and 35 minutes. Okay, let's finish off with a slightly harder question. Here we've been asked to find the values of 2 pronumerals, alpha and beta. So we'll start with alpha, and we're going to do exactly what we've been doing so far. So we'll start with labeling the sides, start with the hypotenuse. The hypotenuse is 18. Locate the angle. Opposite the angle is the opposite side. Next to the angle is the adjacent side. We have got A and H, which is SOC, CA, TOA, it's cos. Cos alpha is equal to 14 over 18. Take our cos over the other side, becomes inverse cos. Alpha is equal to inverse cos of 14 over 18. We've been asked to the nearest minute, so when you get the readout, press the degrees, minutes, seconds button, and to the nearest minute, we've got 38 degrees, 57 minutes. Now, you've got a choice here. You could do exactly the same thing with trig and just do it with angle beta. Or we can recognise that the angle sum of a triangle is 180 degrees. So that's what I'm going to do. So I'm going to do 180 degrees, take away 90, take away this angle, it's going to give me beta. You're going to have to do a bit of juggling to put this in the calculator. 180, take 90, take 38 degrees, 57 minutes. And when you get your readout, it's going to be a decimal. So you're going to have to press the degrees, minutes, seconds button again. And our answer is 51 degrees and 3 minutes. Now I just want to alert you to a common mistake. Sine and cosine always have values between -1 and +1. They never go outside of that range. If you have a look at the trig graphs, which we'll do next year, and the trig tables, you'll see that. So if you don't follow SOHCAHTOA perfectly, you could get an error. I'm going to show you what I mean. Now let's do this question from the beginning. Start by locating the hypotenuse, which is here. Here's our angle. This side here is the opposite, and this one here is the adjacent side. And so we've got adjacent and hypotenuse, and so SOC, CA, TOA, it's cos. Now suppose we didn't follow this in order, and we did. Cos of the angle is equal to 18 on 14. Can you see why that's wrong? Hopefully you can. Now let's take the cos over the other side, and we get alpha is equal to inverse cos of 18 on 14. And 18 on 14 is greater than 1. So when you put this in your calculator, it's going to give you a math error. Now that can be a good thing because it's giving you a reminder that you must follow SOHCAHTOA religiously in order. Okay, that's it for this lesson. Our next lesson, we're going to look at angles of elevation and depression.